Hi everyone, welcome to Om Learning Lab. Today we are going to solve one problem from LeetCode's top 150 problems for coding interviews. Namely, we'll be solving the valid parenthesis problem. Now, some of you might be already aware that this is one of the most widely asked problems in coding interviews. Without any further ado, let's go to the problem. Now, here we'll be solving the problem. We'll first understand how to solve the problem. Followed by that will be the implementation. And the catch is I'll be implementing the code both in C++ as well as Python. Python is quite in demand these days, and in a lot of coding interviews, they are specifically asking candidates to code in Python, especially if the roles are related to machine learning. So, let's get started. Given a string S containing just the characters normal, simple braces, curly braces, and square braces, determine if the input string is valid. And they have given some conditions for the input string to be called valid. Open brackets must be closed by the same type of brackets. Open brackets must be closed in the correct order. And every closed bracket has a corresponding open bracket of the same type. So what they basically mean is that if there is an open bracket of a simple type, it must be closed with the simple type as well. Similarly here, simple open, simple closed, square open, square closed, and curly open, curly closed. This is false because we have a simple open and a square close. So this condition is important because, open brackets must be closed by the same type of brackets. This violates that condition. So if we go to Notepad here and try to understand, so what are they given us? So we have three types of brackets: simple, curly, and square. And we are supposed to determine if a string is valid. And for the string to be valid, open brackets must have a closing bracket and it must be in the right order. So for example, if I have a square bracket open, it cannot be followed by a closing bracket, which is a simple closing bracket. Now, the data structure that comes into mind, let's just understand this a bit. So for example, before jumping into the data structure to use, let's try to understand this a bit more. So for example, if we have, let's say the string S has opening bracket, has a closing bracket to begin with. Can it ever be valid? It can never be valid because as per the given conditions, every opening bracket must have a closing bracket. Like we cannot have just opening brackets or just closing brackets. Please focus on this condition here. They are saying that open brackets must be closed by the same type of brackets. Open brackets must be closed in the correct order. And every closed bracket also has a corresponding opening bracket. So we cannot have, we can't just have closed brackets as well. So if a string starts with a closing bracket, definitely it's gone. It cannot be a valid input string because even if we have a closing bracket to begin with and then an opening bracket, it's not the correct order. This is the correct order. Open then close. Right. So we need to have opening brackets to begin with and they need to close in correct orders. So the data structure that comes in handy for such a situation is a stack, because stack is very good at maintaining order. So stack has this property of last in, first out. What does a stack do? So if this is a stack and I have some elements, let's say E1, E2, E4, E6, let's say inserted E6 first, then E2, then E1, and then E4. The last in element, this is last in, is E4. And if someone told me to show me the element which is in the stack, like remove an element from the stack or pop an element from the stack, as it is usually told in the programming language, so we'll be popping E4. So this is last in, but it is first out. So that's the kind of rule it follows. LIFO, last in, first out. And that is quite handy in this situation because we can track the opening brackets, and whenever we meet the corresponding closing bracket, we can just pop it. For example, if we have a curly bracket to begin with, then a simple bracket, let's say, then we cannot have this, right? We cannot have a square closing bracket. That will become invalid. Instead, we must close this opening bracket with a valid closing bracket of the same type. So our stack would look like this, then this, then once when we're encountering this, the closing bracket of simple type, we'll of course check if a corresponding type is present or not. If it is present, then just pop it. This becomes a pair and just remove it out of the equation. Then what we are left with is a curly bracket and a closing square bracket. So the input sequence is still invalid. But on the other hand, if we had something like this, then this forms a pair, valid pair, and is popped out. And then what we have left is this. And of course, the closing order for this is correct and this string is correct. So we can use stack data structure for this particular problem. We'll start storing the opening brackets. The moment we encounter closing brackets, we will check if the topmost element of our stack has a corresponding opening bracket or not. If the stack is empty, it means of course the string is invalid. It is basically this case that I was talking about some time earlier. Right, so we have closing bracket, but it does not have any corresponding opening bracket, so it is invalid. But if we have a closing bracket and our stack, the topmost element of the stack has a corresponding opening bracket, then it forms a valid pair and we can pop and we can look at the rest of the remaining brackets, whatever is remaining. But if let's say the topmost element in the stack, the opening bracket is not of the corresponding type, then of course the sequence is invalid. For example, if you have a square opening bracket and a curly bracket followed by a simple closing bracket and again a square closing bracket, this is not a valid pair. This is not the right way to close. Hence, this becomes invalid. In this case, our stack would look something like we have a opening bracket of square form, then a curly bracket. Then the moment we encounter a closing bracket of simple form, we'll check the topmost element of the stack. Is it matching? No, it's not matching. Hence, we'll just return no. It's not a valid input string. Now, keeping this in mind, let's go ahead and try to implement this in C++. Alright, so this is a Boolean function. We have to return true or false. We have a string s. Let me define a stack. I'll be storing characters here. So let me call it something like ss. I would generally define a stack as s, but here we already have a variable called s, which is the string, input string. So I'm just defining the stack as ss. Then let me do something like for char. So for every character c in string s, if c is, well, if it is one of the opening brackets, right? So if it is a simple bracket or c is a curly opening bracket or c is a square opening bracket, which we don't have to do anything. So we just need to insert it into the stack. ss dot push, is it? So we'll just push c. Else, what can it be? It can be one of the closing brackets. So if it's a closing bracket, first of all, stack cannot be empty. Remember, if stack is empty, it just means that we do not have a corresponding opening bracket of the same type. This condition is valid. Okay. So if it is in the else condition, what we can do is we'll have three conditions. If let's say c is simple closing type, else if c is, let's say, curly closing type, else it must be a square closing type. So if it is a simple closing type, what we can do is, let's say if ss dot empty, is it empty or dot is empty? We'll see. So if ss is empty, that just means a corresponding opening bracket is not there. So we'll just return false here and we're done. Else if ss dot top, the topmost element, is a simple opening bracket, then ss dot pop. and that's it. Else return false, because the topmost opening bracket is not of the same matching type. As simple as that. Now the same thing we'll have to repeat for the rest of the cases as well. So I might as well just copy this because it's going to follow the same structure. Of course, we can have optimizations to the code to reduce the length of the code, but I'm keeping it as simple as possible so that people can understand it easily. Now if ss.top this is curly bracket, so we'll have a curly opening ss.pop or otherwise it's not present, so we just return false. Same goes for the square bracket. Sorry. So what happens here, if we have opening bracket, we are pushing it into the stack. Otherwise, if it is a closing bracket, we are checking if our stack is empty, that condition 3 is violated, that is our closing bracket is not present, so return false. Otherwise, check if the topmost element of the stack is of the corresponding opening type. If it is so, then we just pop. We pop because we have found this. We have found a matching pair, right? So we just pop it. Otherwise, we'll return false, that the topmost element present in the stack, although it is an opening bracket, it is not of the desired type. We do this for all the cases, right? So we have 3 cases: simple, curly, and square bracket. So for the 3 cases, we do the same thing. And that's pretty much it. Just one condition is remaining. It's very easy to lose this side case. So we have taken care of condition number 2 and 3 now, if you pay attention. 3 is taken care of basically by these statements that if stack is empty, this takes care of condition number 3, that we need to have some opening bracket. Condition number 2 is taken care of because of the this else condition, that even if there is some opening bracket in the stack, it must be of the same type. So these else conditions take care of condition number 2. However, condition number 1 is still not taken care of. That is, open brackets must be closed. So they must be closed by same type of brackets, that is fine. But they must be closed, right? We can't have simply open brackets. That's one case that we need to be careful of. So let's say input string was something like this. It is still invalid because it is not closed. So ultimately, our stack has to be empty. Our stack has to be empty. So you can just check it. If not ss.empty, return false. Else, of course, will return true. So is it empty or is empty? I'm not sure. Let's try to run and see. Oh, it's passing. I think it's empty works. So let's go through the conditions once again. I'll go through the code once again. This is just to make sure that we are not missing anything. So whenever we have open brackets, we are pushing it onto the stack. If it is a closing bracket, if the stack is empty, then condition 3 is violated, will return false. Otherwise, if there is something in the stack, it must be of the same type, condition number 2. So that's taken care of, that's fine. And we'll also take care of the side case that open brackets must be closed. So if the stack is not empty for some reason, it means that corresponding brackets were not closed. If corresponding brackets are closed, stack will be empty, right? Because we are popping those pairs out. So if stack is not empty, we return false. Otherwise, we will return true. Let's try to sum it. Okay. Yeah, it is submitted. Cool. Now, like I had told, I'll be implementing it in Python as well, because these days they are asking candidates to particularly implement the solution in Python. So I'll be doing that. But I think this is it for this video. This is the C++ implementation for this particular problem. For Python implementation, I'll be making a short video sometime later, and I'll add the description of that video in the description. Please go ahead and check that out. This is all for this video. Thank you for watching.